Hello everyone and welcome back to Jack's Labs. Today we will be doing the conductive and not conductive Play-Doh lab, but first let's go over some key vocabulary and terms. The first term we'll be going over is conductivity. Conductivity is the degree or the ability of which a material conducts electricity. The opposite of that is resistivity. Resistivity is the measure of the resisting power of a specified material to the flow of an electrical current. Next, on to solutions. We've gone over this before, but just to recap, solutions is liquid mixture in which the solute is uniformly distributed within a solvent. Our next two terms are ionic compounds, which are compounds made of ions and have a net positive or negative charge. And some properties of this is they have high melting points, hard and brittle, and they conduct electricity. And on the flip side, covalent compounds are molecules formed when two or more atoms are connected with a covalent bond, and then the properties of them are low melting points, are soft, and they can't conduct electricity. Now that we've gone over the vocab, let's get into this week's lab. The materials that you'll need for this lab, starting with the Play-Doh creation. You'll need flour, sugar, salt, distilled water, which means it's deionized, lemon juice, vegetable oil, a medium-sized non-stick saucepan, a stirring spoon, a cookie sheet, and a mixing bowl. And then when we get to the circuit creation, you're going to need 3 LED light strands with battery packs. The battery packs are important. They can't be plug-in. You'll need AA batteries, wire strippers, and then possibly a multimeter, but that's optional. To get things started, we're going to make first our conductive Play-Doh. So first we're going to take our saucepan and we're going to add 1 cup of water, we're going to add 1 cup of flour, a cup of salt, you're going to add 9 tablespoons of lemon juice, and then you're going to add 1 tablespoon of vegetable oil. Once you have all those ingredients in the saucepan, you're going to place it over medium heat and you're going to stir continuously until that mixture thickens. Keep stirring until that mixture forms a ball. Once you form a ball, you're going to want to roll it out and place it on a cookie sheet. That's it for the first ball. For the second one, you're going to take a mixing bowl this time and we're going to add 1 cup of flour, a half a cup of sugar, 3 tablespoons of vegetable oil, and then you're going to stir all of that until the oil is absorbed. And then once you have those 3 ingredients, you're going to start adding in that purified, distilled, deionized water into the mixture until that water is absorbed. There's no specific amount. You just want to feel it out and make sure that it's able to absorb the water so it clumps up. You're going to take it and knead it out and create balls just like we did with the conductive Play-Doh. So now once we have those 2 different types of Play-Dohs, we're ready to start the actual circuit creation. So you're going to take your 3 LED strand with battery packs and you're going to cut off each of the battery packs. You're going to use wire strippers to strip off the outside coating of the wires. Once you do that, you'll have 3 different battery packs with the wires exposed, both the positive and negative. This is where the multimeter comes in handy. If you use a multimeter with the batteries already on, you can see which ones are positive and negative, so you can hook up each of them to the specific side. So you're going to want to put positive with negative. You're going to link all 3 of those battery packs together. And once you do that, then you can place the ends of the battery packs inside 2 balls of the Play-Doh, first with this conductive. And then you're going to take a cut off piece of the LED strand and place it as a bridge between the 2 Play-Dohs. It's a little bit harder to explain, so that's why the visual on the screen right now is showing you how the conductive Play-Doh was able to make the light flicker. And that's because of the hydrogen ions in the lemon juice. You're going to repeat this process, except you're going to change out the Play-Doh for the non-conductive Play-Doh, and since it doesn't have anything to travel on, the light is not going to turn off. Once you do that, the experiment is completed. You see how the hydrogen ions in the lemon juice is able to complete the circuit of the battery packs and make the light turn on. That's it for the lab. Thank you guys for watching, and I'll see you in the next lab.